the undergraduate speaker, Giulia Socolof. She's originally from Summit, New Jersey, and is graduating with a bachelor's degree in physics, having worked during their time here as an undergraduate on enhancing sensing capabilities of optical gyroscopes with their advisor, Professor Michel Digonnet. She will continue the studies at Stanford in the fall with the computer, in the computer science master's program. Please welcome welcome Giulia along with me.
Hi, everyone.
Hi.
So to start, just a brief anecdote that I'm sure you've all experienced something similar sometime in your lives. So I went to the dentist a couple weeks ago, and we were making small talk, and she asked what I was studying, and I said, I'm sounding somewhat like a whale because my mouth is full of dental instruments, but I said physics. And immediately she goes, I hated physics in undergrad, it was always way too hard, terrible subject. So my first thought is well, it's not really what I want to hear while you're drilling away at my teeth. But she did make me think. Many of the responses I get when I tell someone that I'm studying physics are, a combination of being impressed and being interested, but always with this underlying sentiment of physics is really difficult. So first, take a moment to all the graduates to pat yourselves on the back. We have undertaken and successfully completed a rigorous and demanding program. And take a moment to thank your families. I will always appreciate the endless support and listening ear. And today, in the room where I actually had my first ever physics class at Stanford, shout out Physics 45, I want to talk about why we have chosen this difficult path, and more so, how our thinking has been challenged and transformed for the better. It's both a challenge and a long-term benefit that physics is so creative. For example, we figured out how to design a single sheet of 8 by 11.5-inch paper to fit as many equations as possible before taking an exam. In all seriousness though, to paraphrase the great Richard Feynman, physics cannot be learned by rote, and our knowledge must be robust, not fragile. We devise experiments and build theories to uncover the secrets of phenomena from the structure of the atom to the formation of black holes, and it takes tremendous creativity to imagine worlds which are so vastly different in size or so far away. So creativity gets us through this design phase, but to see things through to the end, as I'm sure you all know, requires pure and immense grit. The 24-hour take-home final in my classical mechanics class, though necessary to give enough time to think through the difficult problems, was one of the most grueling endeavors of my life. I'm pretty sure I cried somewhere in there. Also one of my favorite classes at Stanford. So all of you can probably also point to moments in your careers where, through sheer force of will, you've finally been able to resolve a thorn in your research, or solve a difficult problem on a problem set, or resolve something else that's plagued you for days, weeks, or even months. And I'm sure we've all encountered these moments, as I did sophomore year, struggling through intermediate electricity and magnetism, when I asked myself, why do this? Physics is grueling and hard, and often the payoff doesn't come. I mean, the universe is not yet understood. This is why we're all still here. So how did we all make it here with our degrees today? And more importantly, what should we carry forward? I implore you to always remember the joy of it, the beauty of physics, and our utter fascination with the world. Some of the best memories of my time at Stanford are just sitting in a room at 2 or 3 in the morning, working through this absolutely brutal problem set and just laughing all the while. And I've learned to know when not to take things too seriously. I also advise you to appreciate the problems itself that you are working on, and the elegance of the solutions. The pure satisfaction of drawing an immaculate diagram or watching a short, clean answer fall out of a mess of algebra is frankly unmatched. But more broadly, an appreciation for elegance means focusing on finding the balance between completeness and simplicity. Few dilemmas in life have simple solutions, but physics drives us to distill a problem as much as we can and appreciate what we have left to understand. Finally, carry with you a sense of wonder. Do you remember how you felt the first time you rubbed a balloon on your head and you saw your hair stand up? I always want to approach the world with that combination of how and wow. Knowing how much of our physical world can be described by the laws of Newton or Maxwell, and at the same time, the sheer mystery that remains to be discovered. never ceases to amaze me. In physics and in the rest of your life, confront the unknown with fascination and a desire to learn more. Many of us are moving on to further graduate studies, the undergrads, and of course the doctoral candidates moving on to postdocs, professorships. And to those of you I say good luck, and when you win a Nobel, we fully expect a shout out in your acceptance speech. Some others of us are taking time off to travel or enjoy spending time with family, and others are beginning careers in the sciences, engineering, business, the arts, and so much more. Wherever you end up, I hope you carry these lessons with you too. Look for alternate and unconventional solutions. Work hard when you need to. Appreciate simplicity and complexity. And never forget the friendships that you make along the way. Though the future ahead is never certain, know that the most wondrous things in life always begin as mysteries. Thank you.